Welcome back, ladies and gentlemen. We are in College Algebra Chapter 5, Section 2. Today we're going to take a look at, in this video, graphing polynomial functions. So as we take a look, we're going to do two things, graphing by hand and graphing with a graphing utility, graphing calculator. So we have multiple steps here that we can follow along the way as far as how we can do this. The first item that we want to take a look at is graph the polynomial function f of x is 2x plus 1 multiplied x minus 3 quantity squared. Our steps here, step by step, we're going to walk through each one of these. Determine the end behavior of the graph. Find the x and y intercepts of the graph. Determine the real zeros of the function and their multiplicity. Using this information, determine whether the graph crosses or touches the x-axis at each x-intercept. Step 4 will determine the maximum number of turning points on the graph of the function. Step 5 will put it all together. We'll help establish a y-axis scale. We'll find additional points on either side of the graph to help us find either side of the x-intercepts. Now, when we do these, we do not have to do these in this specific order, but since this is the order that our text references these, we will go ahead and put these in this particular order as well. So when we take a look at this particular function, 2x plus 1, x minus 3 quantity squared, first thing is determine the end behavior of the graph. So when we do the end behavior of the graph, we need to know what's the highest degreed term that we'd end up with. So if I would go ahead and take this f of x, I've got this 2x, and I've got this x squared. So this is going to look like, so let me go ahead and put an arrow here, it's going to look like 2x multiplied by x squared, which means it's going to look like 2x cubed. So the end behavior, and because this is a positive as well, the end behavior, one side is going to be down, the other side is going to be up. Because when we take a look at our odd functions have that component to them. The odd functions, the ends do opposite items. If I would go back and take a look at Desmos here, take a look at Desmos, and I go ahead and say, all right, what does the x cubed function look like? So this is what the function look like at the ends of the graph. So the left side going down, right side going up. That's what the end behavior will look like. So I could say here opposites. Okay, so that's our end behavior. Step 2, find the x and the y intercepts of the graph of the function. So to find the y-intercept, we let x be 0. So really what we want is f of 0. So we've got 2 times 0. Let's clean that up a little bit. 2 times 0 plus 1 multiplied by 0 minus 3, that quantity squared. Let's clean that up a little bit. So that's going to give us, let's see, that's 0 plus 1 is 1. And we got negative 3 squared is going to be positive 9. So my y-intercept is going to be 9. To find my x-intercept is when does the function go to 0? So when does 0 equal 2x plus 1 multiplied by x minus 3, that quantity squared? Using the zero product property then, either then 2x plus 1 must be 0, or x minus 3 squared must be 0. So if we start solving, we'll subtract 1 from both sides. Then we'll divide by 2. So we end up with 1 x-intercept is negative 1/2. And then we take a look at our other intercept. We take the square roots on both sides. So square root of 0 is still 0. Add 3. So we have another x-intercept at 3. So these are the, we'll put this y-intercepts and x-intercepts. So we know some things about our graph already then. We got step 1, step 2. Step number 3, let's determine the real zeros of the function and their multiplicities. So the real zeros are when the function goes to 0. So these are the x-intercepts, okay? So these are the x-intercepts that we're interested in. And we know then that we have an x-intercept equal to negative 1/2 and an x-intercept equal to positive 3. That's what we just figured out over here. The other thing we want to figure out is their multiplicity. So if we take a look at the original, so this 2x plus 1 was to the power of 1, so this has a multiplicity of 1. Then we have the x minus 3 with the power of 2, so it has a multiplicity equal to 2. So what that means then, overall, when we want to figure out does it cross or touch the x-axis at each one, if we have an odd multiplicity, we go through the axis. If we have an even multiplicity, we touch the axis. Okay? So as we start piecing together our graph, okay, so what we know so far is we have at -1/2 that we're going to have an x-intercept, a +3, another x-intercept. Up here at 9, 0, 9, we have a y-intercept. So we know we have those things already. We also know then that the graph has to follow, as far as the end behavior, we have to do opposite things. So we have to be negative down over here and going positive up down this direction. So what that tells us then, we must do something like this, because we had to go through x equals -1/2, and we had the touch at x equals 3. So that gives us a very nice piece of information. So we already know some base elements of the graph. Now, we don't know how steep this is in between here and how steep this is, or how fast that goes up on the other side, but at least have a rough sketch of what we have. Step number 4, determine the maximum number of turning points of the graph of the function. So we take a look at our degree. Our degree we label as n, and that's going to be the same as what our end values were as far as our end behavior. So since we're looking at 2x cubed as far as our leading term and our highest degree term, n is going to be 3. So n minus 1 is the max number of turning points, or you could say just max number of turns in general. So we get 3 minus 1, so that means 2. So maximum of 2 turns. So if I take a look at what I've got sketched so far, I'm going to have a turn somewhere in here between -1/2 and 3. And I'm going to turn, I know for sure, at 3. So those are going to be my 2 turns that I have overall. Step number 5, put all the information from steps 1 through 4 together to obtain the graph. So we've already got most of that already done. But to help establish the y-axis scale and to find what we're going to do then is find additional points on the graph on each side of the x-intercept. Okay, so let's take a look at this over here. So what if I figure out I want something on the left side over here of -1/2? So how about -1? Okay, so when we do that, our function was, let me write our function back up here, f of x is 2x plus 1 multiplied by x minus 3 quantity squared. So if we plug in -1, then I got 2 times -1 plus 1 multiplied by -1 minus 3 squared. Let's figure out what this works out to be. So that's -2 plus 1 is -1. This is going to be -1 minus 3 is -4 squared is 16. So that means at -1, I'm -16. And we already have a value in between -1/2 and 3. We got 0. Let's pick another point in 3. Let's go on the right side and maybe figure out how we're doing up over in here. So let's do f of 1. And again, when we choose these points, you can choose any point we want. The key here is that we're choosing a point on the left side of -1/2, somewhere in between -1/2 and 3, and then we'll also pick a point somewhere on the right side of x equals 3. So on this one, we'll have 2 plus 1 multiplied by 1 minus 3 quantity squared. Be a plus sign in there. So that's 3 times the square of -2. So the square of -2 is 4. So f of 1 then should end up being 12. And let's pick another point on the right side of 3. Let's go ahead and just pick it 4, just a little bit to the right there. So then we'd end up with 2 times 4 plus 1 multiplied by 4 minus 3 squared. So it's going to be 8 plus 1 is 9. 4 minus 3 is 1. Squared is just 1. So f of 4 then is going to end up being 9. So that allows us to come back into here to our graph and go ahead and write this out a little bit nicer. So let's see, so I want to go up as high as 12 and as low as -16. So let's see, maybe I count by 4s. 1, 2, 3, 4. and negative 4, 8, 12, 16. And let's see, we got 1. And the x's and y axis don't have to count by the same thing. So I'm going to do 1, 2, 3, 4, and then 1. So negative a half is in through here. At 0, we were 9. And then at 3, f of 4, we were again at 9. What do we say? At f of, what were other values here? F of 1, we were 12. So just plotting some points. And think at f at negative 1, we were negative 16. Yeah, negative 1, we were negative 16 over there on the left. So now I can go ahead and connect these with hopefully a fairly smooth curve here. Now this item here, I don't know if that's the peak. I don't know if I'm going, if I should go up a little steeper through there, or if it's already gone up and it's on its way back down. I don't really know that. I have to plot a few more points to figure that out specifically. But overall, now we have the graph, a nice sketch of the graph of our function. Leaving that out through there. Okay. Now, if we go ahead and we put that into our graphing calculator, so I'll just plug in Desmos here real quick because Desmos is so much quicker than any other graphing utility. So here's our graph. Same graph as what we have. Okay, so let's see here. So we're at negative a half 0. We're at 3, 0, so we crossed. Up here at 2/3 would have been our highest point. 0, 9, we did what the point 1, what do we have? 112 is what we had. Okay, so our point, our graph that we ended up with is really, really close to what a computer-generated graph would look like also. Okay, so if we just followed the process and procedures, we get to know more of what this graph looks like. And we did this whole graph here. We did this really without a calculator. So the whole thing without a calculator. Pretty slick in the age of technology and whatnot. So let's graph another one. Let's graph x minus 2. Multiply that quantity multiplied by x plus 3 quantity squared, multiplied by the quantity of x minus 5. Okay? So as we do these, one of the things we might want to take a look at, and again, these steps do not have to be in this order, okay? But we do need to figure these things out. Let's figure out our end behavior. See, we've got an x multiplied by an x squared multiplied by another x. So we're going to have x times x squared multiplied by another x is going to end up being an x to the 4th. And because this is all positives, our graph, our end behavior is going to look the same. So we're going to be up on both ends. Now, I'm not sure what all this stuff in the middle is going to do, but at least know on either end, on both sides are going to end up going in the positive direction. Step number 2, we want to define the x-intercepts and the y-intercepts. Okay, so let's see what we can do here. So for the y-intercept, we're going to have f of 0. So f of 0 then, in this term, we get negative 2. This term here is going to be 3 squared. And this term over here is going to end up being negative 5. So f of 0 then is going to be, what, 9. And we've got double negative there, makes that positive. And that's 2 times 5 is 10. So 9 times 10 is going to end up being 90. The x-intercepts, that means 0 is going to equal x minus 2 multiplied by x plus 3, that quantity squared, multiplied by x minus 5. And then by the zero product property, each of these things has to be set equal to 0. So 0 could be x minus 2, 0 could be x plus 3, and 0 could end up being x minus 5. So if we solve each one of these, if I add 2 to both sides, one x-intercept is going to end up being 2. Subtract 3 from both sides, so another x-intercept will end up being negative 3. And if I add 5 on both sides of the other one, another x-intercept is going to be x equal to 5. So now we have all of our x and y intercepts. Step number 3 is going to end up being our multiplicity. Okay. So that's when we take a look back at the exponents on each of these items. So x minus 2 is going to have a multiplicity of 1. So we're going to go through the graph. Let's see, at negative 3, that's got an even multiplicity. So we're going to touch the graph and turn at the graph. And x minus 5 had exponent up there of 1, so that's also an odd multiplicity. So we're going to end up going through the graph there as well. On number 4, okay, step number 4, we want to go ahead and take a look at our turning points. Okay. And for our turning points, we take a look at, that's going to be the degree minus 1. So since our degree from step number 1 was x to the 4th, 4 minus 1 is 3. So at max, we're going to have 3 turning points. Now we could have less turning points, but we can't have any more than 3 turning points. Step number 5 then is let's come up with some other points in these regions and figure out what we got going on. So overall, if I take a look at my x-intercepts there, I've had negative 3, we've got 2, and we've got 5. So one of the things we want to do then is we want to figure out some points in between each of these regions. So what if we go ahead and just choose some random points. So I'll choose f of negative 5 as a point here. So I would have negative 5 minus 2 multiplied by negative 5 plus 3 squared multiplied by negative 5 minus 5. So that's negative 7 multiplied by negative 2 squared is 4. And that last item is going to be negative 10. So let's see. So that's double negative is going to be positive. So 7 times 4 is 28 times 10 is going to be 280. So this graph is going to go up in a hurry. Okay. Let's see. Then let's take something between 2 and negative 3. Okay. Maybe negative 1 for instance. So that would give us negative 1 minus 2 multiplied by negative 1 plus 3 squared multiplied by negative 1 minus 5. So that should give us negative 3, 2 squared is 4, and then negative 6 at the end. Again, double negative. It's going to end up with 12 times 6. So that's 72. All right, so I got a value in over here. I've got a value between negative 3 and 2. I need a value between 2 and 5. So between 2 and 5, let's choose 3. Why not choose 3, right? Okay, so let's see, back to my function. Yeah, so my function over here, f of x is the same as, we have x minus 2, x plus 3, that quantity squared, x minus 5. So if I'm plugging 3 in, I've got 3 minus 2, 3 plus 3 squared, and then 3 minus 5. So that gives me 1. 6, I was just going to say 9 there for a moment. 6 squared is 36. 3 minus 5 is negative 2. So that's going to be 36 times 2 is 72. We've got one negative sign, so we got negative 72. So it's fairly large numbers on this one. Then the last thing we need to choose, so we need a number out here beyond 5. Okay? So how about let's choose 6. These numbers are getting fairly large. Let's not go too far out, then we're going to get a massive here. So we got 6 minus 2 multiplied by 6 plus 3 squared multiplied by 6 minus 5. That last term is going to be nice. That's just 1. So we got 4 multiplied by 9 squared is 81, and then multiplied by 1. So that's going to be 324. And again, you can check these in the calculator, or anytime we're doing these. Pause the video, take a look at what different components are, and go from there. And then come back, obviously after you've paused it, unpause it, and then come back. So we've got some scale here. So we're going between 280 as a high, 324 as a high value, down to negative 72. So maybe we want to count in this case, wow, how do we want to count that? Maybe by hundreds, okay? So 100, 200, 300, 400, and negatives, let's see, negative 100 here. Then on our other values, we don't have to count by the same thing. We can count by ones in this case, okay? So count by ones, so at least label that piece there, so that's 1. So we do know at 2, we had an x-intercept. -3, we have an x-intercept. And at 5, we have an x-intercept. 2, 3, 4, 5. What else do you know? At -5, 3, 4, 5. -5, we're 280. It's going to be up here approximately. So between 200 and 300, closer to 300. F of -1, we're going to be at 72, so about 3/4 of the way up. F of 3, we're at -72, so down in here. And F of 6, we're at 324. It's 1, 2, 3, 24. It's going to be up in here. So that means my graph is going to look something like this. Where notice I turned here, should be a turn. Whoops, my pen's a little thick there. Gotta love electronics here. So we are turning here at this spot, okay, at -3, going through x equals 2 and x equals 5. And again, we have, wait a minute, I missed my spot in here. Sorry, I left my y-intercept off. Don't want to do that. What was my y-intercept up here? Y-intercept was 90, okay? So y-intercept needs to be right in here. Get rid of this piece. Click, there we go. If I can turn here, come up and around, then turn back down through those. Okay. So now we have the idea of what that is supposed to be and what it looks like. If we would go back and take a look in the graphing calculator, so let's take a look and see what we had. So this was x minus 2 multiplied by, what do we have, x plus 3 squared multiplied by x minus 5. So it looks like we do have an x-intercept at a -3 that we turned on, went through x equals 2, went through x equals 5. And if I go ahead and zoom this out a bit, okay, actually let me go ahead and press this wrench here because I can change my settings. So on my x's, let me go from maybe -8 out to +8, okay, and we'll go ahead and count by ones. And on the y-axis, let's say we're going from, let's say we counted by hundreds. Let's go -100 up to +400, and we'll count by hundreds here. Okay, so now this looks a little bit more closely to what we have as far as our graph. Okay. So then we can see at, what do we have? At f of 3, we were -72. If I come down here and try to pick out f of 3, so yeah, so we're at -72. Over here at around the 100 mark, okay, got 0 and 90 matches up through there, and we can match some other numbers up. So we ended up with a pretty nice graph overall as far as the details of what we're trying to do. So let's take a look at another graph here. Only this one is now we're going to try to do this with a little bit of help from a graphing utility. So we're going to end up using the graphing calculator on this one. So the steps still stay the same. So we're taking a look at this long item here. Because our first term here is an x cubed, our end behavior is going to model the x cubed. So it's going to be down on one side and up on the other side. Okay, so our end behavior are going to be opposites. Graph the function. Now in this case, it says graph the function using the graphing utility. So it's actually asking us to do that first because we're going to use the graphing utility to figure out what these intercepts are. Okay, so on those, I've already got this in. I'm going to go to my calculator here. Got y equals. I've plugged it all in already just to kind of shortcut the process a little bit. And when I go ahead and press graph, okay, there we have the graph of our function. It does seem as though that we have that odd component. The left side is going down, right side is going up. Obviously, this is going to come up through here somewhere in turn, so we'll have to figure out perhaps a little bit more where that is. But our goal here, then in, let's see, step number 3, so we've already graphed it. Use the graphing utility to approximate the x and the y intercepts. All right, so let's figure out where the intercepts are going to occur. So it looks like along the x-axis there's only one intercept here. So we're going to do second trace, and we're going to figure out the zeros of the function. So we're going to do number 2, the zeros and the roots of the function. So left bound, I'm going to click on that. It's going to be on the left side of the 0. Then I want to be on the right side of the 0. Okay, and then it's going to ask me for a guess. And it doesn't matter where that cursor is. It's going to zero in, no pun intended, right here. So I get negative 3.79116. My y value is negative 2e negative 12. So this can confusing at times for students. What that means in that e in this particular calculator is scientific notation. So that is negative 2. Let's see, negative 2e negative 12. So if I take a look at back over here, so negative 2e negative 12 means I've got negative 2 times 10 to the negative 12 power. So when we do scientific notation, if you remember, if we have this item out here, that means move the decimal this number of times. So I'm going to move it to the left 12 places. So it'll be negative 2. There's the decimal so far. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have the negative out there, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros, and then the 2. That is an exceptionally small number. Practically, that's 0. So every once in a while, the calculator does not give us the 0, the value, but it gives us something that's horrifically close. I mean, very, very, very close overall. So when we see that, we're just going to call that the 0. So our zeros of the function, let's go back through, is going to be at negative 3.79. Okay, so the x-intercept is going to be negative 3.79. Now let's take a look at the y-intercept. So we take a look at the graphing calculator up over here. And so somewhere in here, we need to figure out what the y-intercept is. And so on these, I can go ahead and take a look at value. So number 1. Like I said, what does my x value supposed to be? Well, my x value is 0. That would give me the y-intercept. So the y-intercept, 2.48. So again, how did we get that? We went to the second and then the calculations again. And we can get any value we want for our x's, and it gives us our y value back. So we typed in 0, and we figured out 2.48. Now, number 4, use the graphing utility to create a table to find points on the graph around each intercept. Okay, and so if we're at negative 3.79, we might want to go ahead and choose, okay, what's negative 4, and maybe what is negative 2. So those would be points. So if I'm around over here, if I'm counting, there's negative 2, negative 3, negative 4. So I know at negative 3 I'm at 0, but what are we at negative 4? What are we at negative 2? Now, the directions here said use a table. So we could go ahead and take a look here. We've got the table up here next to the graph button, so I can do second table. I can see these. So at negative 4, I can just read through these. Well, we have a negative 3.79, we had a 0. So at negative 3.79 on my, when I did these over here, I put my intercept at negative 3. Negative 3.79 is really the intercept. So maybe I want to choose negative 4 and negative 3 for my values. That would probably be a little bit better. So at negative 4, I'm negative 4.56. Actually, I was going to say negative 4.6, but negative 4.57. Okay, so negative 4.57, and at negative 3, we're 10.75. So we have some values there. That says approximate the turning points of the graph. So where does this graph turn? Okay. Now, one other thing we could have done as far as instead of this table, could have gone back to the trace command and the value, And then in the values, we could have typed in -4 and gotten a little more precise value here. Could have done the same thing at -3 and figured out a little more precisely there as far as a few more digits as far as what we wanted. So we still want, in this case, want to approximate the turning points on the graph. So this point here is going to be a turning, and this is going to be a minimum value because we're coming down and we turn back up. So that's a minimum. So when I go to my second calculations command, I can do a minimum, which is number 3. And it's going to ask me, where's the left bound? So let me figure out where's my mouse currently. So the cursor is to -1. There it comes. All right, coming back down. So I just make a click. You go to the right side of where it is for the right bound, and then just press the enter key. So at approximately 0.6299. So I'm going to say, if I round this, because I've been doing everything to 2 digits, I'm going to say this is 0.63. So 0.63. And what was my, I should have taken a look at that. What was the y value? Oh, y value of 1. Okay. And let's figure out another value here. And I need this other value up in here. It's not going to find that value unless I have this in my grid, in the visible area. So let's go ahead and go back over through here. What if I, just to illustrate, let's do the trace. Now we're going to have a maximum in this case, so the graph was going up and then back down. So that's the max. We'll say number 4 here. So the left side. Okay, so there's the left side. Let's go to the right side. And let's enter. I don't think this will find, actually it did. I'm surprised at that. Okay, so nice. I thought some of the other calculators, you actually have to be able to see it on the grid to determine where that is. So -2.28, -2.28, and then what was the y value? 13.36. All right, so those are our values. So number 6 here, use the information to draw a complete graph of the function by hand. Okay, so let's take a look at what we have here. So we know we have our intercepts. X-intercepts were -379 and 2.48. Let's go 1, 2, 3, 4. So we got -3, -2, -1, -4 out there. And let's see, and then we went out to the right, matching up our x-intercept. Oh, we only had one x-intercept there, didn't we? Okay, but we also had some values out here where we turned. We turned at 0.63, so we don't have to go out too far here. Let's go out to 1. And then as far as our y values, let's see, we had some values on either side. We went -4.5, 10, and so maybe on these, there's not, here's only 13. Maybe we only go out to 15, so maybe count by 5, so 5, 10, 15. Go down by 5s also, so -5, -10, -15. Let's figure out, so we had an x-intercept at -3.79, so we'll plot that one. We had the y-intercept at 2.48, so we'll plot that. Then we also had some other interesting points. -4 was -4.57. -3 was 10, so it's going to be up in here. Let's see, at 0.63, we were at 1, so way down here. And -2.28, we're at 13, so that was where the turning points were. So we know we're going to have something that comes up here. And then, let's see, this also was a turning point. You know, we should probably pick out another value. Let's pick out at 2. What are we? Okay, so at 2, so let's do the second trace command. We'll do a value at 2. And at 2, we're 11.77. So f of 2 is 11.77. So at 2, we're up back here again, because that means I know my graph's going to go up that direction. So there we go. Nice little graph. You will be asked to do this on some of the concept checks as far as being able to do a graph of a function and doing it, help with the graphing utility, the graphing calculator, but then do those by hands. Now, the follow-up question on this one is number 8. Use a graph to determine when the function is increasing and decreasing. So when are we increasing? So we're increasing between this area from negative infinity up to this turning point. And that turning point, what do we have up in there? So we're from negative infinity up to, what was that, negative, where do we have our turning points in there? That was the max and the min. Oh, yeah, step number 5 here. So these are the turning points. So we're going to go up to negative 2.28. And then again over here, so wherever this turned here, and that was 0.63. So we're going to join that again with 0.63 out to infinity. And we can go ahead and put the brackets next, so we're going to include those. Where are we decreasing? We're decreasing only in this region here, so between those turning points. So between negative 2.28 and 0.63. There's the various areas where we were turning. Okay? And so that wraps up all of this section. So graphing polynomial functions, so we had all of these different components. Let me scroll back up to the top here. So we take a look at these steps. They don't have to be done in any particular order, okay? But those steps off to the side, step 1 through 5, we do need to do all of those. And then once we have those, we go ahead and do our graph. We just put all the pieces together. All right, so again, as normal, if you notice any mistakes, please go ahead and let me know so I can fix those. Otherwise, I will see you in another video.